Start. This is Unit 1 for Algebra 2, titled Linear Functions and Systems. We're going over the study guide. Okay, so the first problem we have here, where they're asking us for domain. So keep in mind that we want to know how far to the left the function goes. It might help to draw yourself a little dashed line here. It goes all the way to the x value -4. Because of the closed dot that's right here, we're going to use a bracket. And then we want to know how far to the right it goes. Common mistake would be to think that it stops there at -4, but the arrow tells me that it keeps going towards the right. It'll never stop, so it's headed towards positive infinity, which is a value we can't reach, so we'll use parentheses. Okay. Next thing we want to know is the range. So now we want to know how far down the graph goes. Again, it looks like it might stop there, but the arrow tells me that it's going to keep going downwards. It's going to go basically towards negative infinity, a value we can't reach, so we put it in parentheses. And then how far up does it go? All the way to the y value 3. And again, because of this closed dot right here, we're going to go ahead and use brackets. Okay, next thing we want to know is x-intercept. So where does it cross the x-axis? Here's the x-axis. It crosses it only once at that point right there, which is the x value -3, the y value 0, because you're not going up or down. Then we want y-intercept. So now we're looking at the y-axis. It intersects it here, which is going to be the x value 0 because we're not going left to right. And then the y value is going to be roughly -0.5. Okay. Keep in mind for domain, it is possible to get brackets and parentheses depending on the graph. For x-intercepts and y-intercepts, it will always be parentheses because we're looking at ordered pairs. Okay. Next thing that they want us to calculate is where there is a positive interval. Keep in mind when they say that, what separates positive and negative is the x-axis. Everything above will be positive, and everything below the x-axis will be negative. Any points that actually touch the x-axis, we don't necessarily want to include because at that point y is 0, and 0 is considered neither positive nor negative. All right, so for positive interval, I specifically want this piece of the graph, which again starts at -4. And because of the closed dot, we're going to go ahead and put it in a bracket, and it stops at the x value -3. Parentheses, because again, the fact that at this point right here, the y is 0. 0 is neither positive nor is it negative. Okay, now we want to know where it is negative. So we're going to go from this point, and you could tell there that the graph is going to continue going. Okay, so that starts at the x value -3, again in parentheses because 0 neither increases nor decreases, and then it's going towards positive infinity. I know the arrow looks like it's going down, and it is, but at the same time it's traveling to the right, and we're interested for the x value. So that's going to be positive infinity, parentheses, because we can't reach it. All right. Next question is, where is the graph increasing? So let me just go ahead and erase this work. We specifically want to read this from left to right. Because if you go from left to right, you'll notice that at no point is the graph moving upwards. So that means that there is no increase in interval. So I'll just go ahead and put none. Decreasing, it looks like the entire graph is decreasing from left to right. It starts decreasing at this x value, which is -4. And it keeps going. It looks like it might stop here, but again, the arrow tells us that it's going to keep going towards positive infinity, which is a value we can't reach. So we go ahead and put it in parentheses. Okay. For the next one, I'm not going to explain so much. I'm sort of going to give you the answer so you can check your work. Okay, so our domain for this one is going to be -infinity to +4, both in parentheses. The range will be from -infinity to +2 in brackets. For x-intercepts, we have -4, 0, -2, 0, 0, 0, and 2, 0. Y-intercept, there's only one. If it ever crosses the origin, that's going to be both an x And y-intercept because at that point it crosses both the x and y axis. Positive intervals, that's going to be from -4 to -2. And the other one's going to be from 0 to 2. Negative intervals, we're going to have from -infinity to -4, -2 to 0, and from 2 to 4, all in parentheses according to the graph. Increasing intervals, there's a couple of those. The first one at -infinity to -3, and the other one will be from -1 to +1. Decreasing intervals, again, there will be a couple of those. We'll have -3 to -1, and from 1 to +4, all in parentheses. Okay. The next one we're looking at, we're starting to look at transformations. So we're given the function g of x is equal to -2, absolute value x minus 3. Notice a g of x here. So this stuff right here just tells me that what we have is a function and that what we're plugging in is x. So that's the same thing as y. It doesn't matter if it's f of x, g of x, or h of x. It's equivalent to y, or what would come out. So parent function, because of the absolute values, I'm looking for you to write down the equation y equals the absolute value of x. If it were a linear function, you would just have y equals x. If it was quadratic, you would have y equals x squared. If it was a square root function, you would have the square root of x. Okay. Description. So we're going to want to look at a, because a is negative. The first transformation we're going to have is that the graph will reflect over the x-axis. Okay. Then we want to take the absolute value of a. So the absolute value of -2 makes it a +2, which is greater than 1. So we're going to have a vertical stretch by a factor of 2. Okay. Then we look at h. H is -3, which means we're going to translate to the right 3 units. And then because k is not present, you can assume k is 0, so that means there will be no up or down movement. Okay. So now to graph it on the right, what I strongly suggest is that we graph the parent function first. So I would probably use, like we did in class, keep it down to about 5 values. So -2, -1, 0, 1, and +2. If we take the absolute value of -2, we'll get a +2. If we take the absolute value of -1, 1, of 0, 0, absolute value of 1, 1, and absolute value of 2, +2. Keep in mind that the absolute value, all it does is it makes a number positive. So those are 5 ordered pairs. -2, 2 being our first one, -1, 1 the second, 0, 0, 1, 1, and 2, 2. Okay. Keep in mind absolute values are supposed to look like a V. Okay. Had it been a parabola or quadratic, we would be looking at more of a U function. Okay. Now, once we have the parent function, we're going to go ahead and take the transformations one by one in the order that we wrote them and apply them. So the first thing we're going to do is reflect over the x-axis. So this point will stay there. This point right here will go here. This point will become this one. Sorry, there was a mistake there. This point right there should not have been there. This one should have actually been here for true reflection. And then this one right here will become here. This one right here will become here. Keep in mind we're reflecting over the x-axis. Okay, that's the first one. The next one is the vertical stretch by a factor 2. This is the one that most kids have trouble with. We're going to want to keep these same x values, but we're going to get a new y value. I'll just label it new y. We're going to multiply all of the original y values by 2. Okay, so the first one was 2. If we multiply that by 2, we'll get 4, which will give me the new ordered pair -2. And in this case, sorry, it should be -4 because I'm looking at this one right here. So if I take -2, multiply that by 2, I'll go ahead and get -4. Okay. This one right here had a y value of -1. If I multiply that by 2, I will get negative 2. This one had 0. 0 times 2 is still 0. This next one, negative 1, sorry, multiplied by 2 will give us negative 2. This one had a y value of negative 2 times a positive 2 will give me a negative 4. So I know I probably used a little bit too much green. That looks confusing, but the new one looks like this. Okay, so notice what we had is a vertical stretch. So pretend like that absolute value was sort of made out of strings. Vertical stretch just means we're going to pull it downwards in a vertical fashion. Okay. And then the last thing we have here is a translation to the right 3 units. So we're going to take the green one and move it over 3 units. So from here, it's going to go 1, 2, 3. Looking at this point, 1, 2, 3 is over here. Looking at this point, 1, 2, 3 puts it here. Looking at this point, 1, 2, 3 puts it over here. Looking at that point, 1, 2, 3 puts it here. So the purple one will look something like that. Keep in mind the purple one will be your final one. Okay, and the red one was the one we started with. That's called the parent function. Okay. Keep in mind too, for each transformation, I didn't go back to the parent function. I went from the previously transformed function and then transformed that one, right? So like I started with the parent function, which is the red. Then I used the red one to reflect, which gave me the blue. Then I used the blue one to vertically stretch, and then I used the green one to translate to the right. So purple would be my final answer. All right, number 4, similar concept, but now what we're looking at is a quadratic function, which we know because of the exponent too. So the parent function for that one is going to be y equals x squared. Descriptions. A is positive, so there will be no reflection, so there's no need to write it. We take the absolute value of A, so the absolute value of 1/4 is still going to give us a 1/4, which tells us, because that value is between 0 and 1, that we're going to have a vertical compression by a factor of 1/4. Okay. There's no parentheses, so that means there's no h value. K would be minus a, so that means we're going to translate the function or the graph 8 units down. Okay, so we're going to start with our table. In order to graph the parent function, which is y equals x squared, we'll use the same x values as before. These 5 will be good because we just need a rough idea of what it looks like before we start graphing it. Negative 2 in parentheses squared will give us 4. Negative 1 in parentheses squared will give us 1. 0 squared will be 0. 1 squared is 1. 2 squared is 4. That gives me the 5 ordered pairs that I need. So negative 2, 4 being the first one. Negative 1, 1 being the next. Then 0, 0. 1, 1, and 2, 4. Keep in mind this is a quadratic, not an absolute value. So there should be a bit of a curve to it, right? It should look more like a U than a V. Now, vertical compression. We're going to multiply each of the y values by a factor of 1/4. Okay, so the first y value was 4. 4 times 1/4 gives us 1, so that's the new point. The next original y value was at 1. 1 times 1/4 gives us 1/4, which the decimal equivalent is 0.25. The next y value was 0. 0 times 1/4 still gives us 0. And then the y value 1 multiplied by 1/4 gives us 1/4. The y value 4 multiplied by 1/4 gives us 1. Okay. So now what we have is this green graph that's been vertically compressed. Okay, and then this one didn't have a lot of transformations. The next one just says take the function 8 units down. So looking at the green one, we're going to take it each point down 8 units. So 1. That will put it right here. And the next one will be roughly here, then here, then here, and here. Okay. So the red function will be our final function. We started it with the blue parent function. Then we did a vertical compression, which gave us the green one. Then we translated 8 units down, which gives us the red one. All right, number 5 says use a graph to solve. I'm going to go ahead and get out of tablet mode just because I want to show you how this looks on a calculator. So basically, just to recap what I'm going to do here, I'm going to enter the left side as my y1 into my calculator, and the right side will be y2. So again, I'm just going to get out of this PowerPoint so I can show you what this would look like. Okay. So most of you guys will either have a TI 83 or TI 84. 83 will look a little bit different, but you're basically going to want to go to your y equals. Make sure all your plots are off. Okay. If they happen to be in bold, all you need to do is get your cursor on top of it and then click enter, and that should turn them off. Look through all your y values and make sure there's nothing there. And we're going to enter the first one. So the left side of the equation was x squared minus 2. Here's the x. Squared is this button right here. And then minus, not to be confused with the negative. And go ahead and press enter. The next equation is 2x plus 1. So we have 2x plus 1. Enter. And then when we're ready, we can go ahead and click graph. Okay. You're going to want to give that graph and draw it. But then what we're interested are the points of intersection. So you'll see once we graph it by hand that it's going to intersect at 3, 7, and negative 1, 1. Okay, so that's how you could use your graphing calculator to do this. I'm going to go back to the PowerPoint so that we can graph it and see what it looks like. Okay, so the first one we had was x squared minus 2. So it's going to have a point here, a point here, and here, and then another point right here, right here, and then at 3, 7, and negative 3, 7. Okay, and that's going to be this quadratic one to the left. Now, if we graph the one to the right, y-intercept was at 1, up to over 1. And technically, you could graph these by hand using the skills that we know in the transformations, but it's also possible through your TI Inspire. Okay, we have enough points now to see at the 2 locations at which they will intersect. So we're going to be interested in that point right there and in this point right there. So points of intersection. The one on the left will be negative 1, negative 1. And the one on the right will be 3, 7. Keep in mind for these, we're solving the x values at which they intersect. So I'm only interested in x. So your final answers for these would be x is equal to negative 1 and x is equal to 3. All right, number 6 is similar. It says use a graph to solve. Only difference is the one on the left is an absolute value. The one on the right is linear. So again, I'm going to go ahead and get out of this just so that you can see what it looks like on the calculator. Okay, so I'm going to go back to y equals. I can clear this one, go to bottom, clear the next one, go back up. The first one will be the one on the left, which was absolute value. So we're going to go to math. We want to be here where it says number, so we're going to click the right arrow. Option number 1 is the one we want, so you can either press 1 or press enter. On your 83s, I think it'll say ABS in parentheses. Keep in mind you're going to have to close that parentheses, but the 84s do show absolute value bars. So we'll do x minus, again, not to be confused with the negative. We want to be out of there, so click the right arrow. That takes us outside of the absolute value bars. Press enter. And the next equation was just 2. All graph, and it'll look something like that. So we know when we copy that graph onto the graph paper, that it should look something like that. Okay, so let me graph these by hand real quick. The one on the left will start here. And then the one on the right, 2, is technically the equation y equals 2, which is going to be a horizontal line going through the y value 2. Okay, so again, what we're interested here is the points of intersection. So we're going to be looking at this point right here and that point right there. So the one on the left was 1, 2, and the one on the right would be 5, 2. And we're only interested in the x values. So final answer will be x is equal to 1 and x is equal to 5. Okay. Number 7 is definitely one that you want to use solving your graphing calculator. And the only reason for that, examples 5 and 6, we ended up with whole numbers as points of intersection. That won't always be the case, and you'll see with number 7 that you can actually, it's possible to get some tough looking decimals. So again, going back to our TI Inspire, go back to y equals. Keep in mind, if you ever want to get out of a specific window on the calculator, you can always just press second, quit, and it'll take you back to the home screen. We have y equals, let's clear that. Clear the previous one too, go back up to y1. The left side, we need to enter -1/2. When it comes to fractions on the calculator, I like to put them in parentheses to avoid any issues. This time around, we do want the negative, so 1 divided by 2 for the fraction. Close it up. Then we want the absolute value, so we're going to go back to math, number, enter for absolute value. Inside, we want x plus 2. We want to be out of the absolute value, so click the right arrow, and then we can go ahead and click +4. Okay, press enter. Second equation will be the right side of the equation, so that'll be x squared plus 2x and a -4. Okay, then go ahead and click graph. So there are 2 points of intersection. So we're going to go second, trace, which is calculate. Specifically, we want to calculate the intersect, so we can either scroll down to 5 or click 5. It's going to ask you for the first curve. That just means the first graph. That's the absolute value. Click enter. The next graph for the second curve is going to be your quadratic because it's the second one we entered. Click enter one more time. It's going to tell you to guess. At this point, because there's 2 points of intersection, you're going to want to use the left and right arrows to get your cursor close to the one you're interested in so the calculator knows to calculate that one. Okay, this is pretty close. Click enter, and it's going to give us the point of intersection. Remember, more than anything, we're interested in the x value. And I'm going to go ahead and say for this one, let's just round to 1 decimal place or the tens place. So that'll be the same thing as x is equal to -3.8. Okay. Now we want to find the second point of intersection to the right, so we're going to go back to second calculate, option number 5. First curve, enter. Second curve, enter. Again, where it says guess, use the right and left arrows to get us to where we want to go. Okay, now we want the one on the right, so we want to get the cursor as close as possible. Click enter, and it gives us a new intersection point. Round it to 1 decimal place. That's going to be x is equal to approximately 1.7. Okay, go back to the PowerPoint. And I'll just write down the answers I said. So the 2 answers were x is equal to -3.8 and x is equal to 1.7. All right, number 8, we can solve these algebraically, 8 and 9. So 8 is an equation. We'll drop our line down the middle. Multiple ways of doing it, but this is just how I would go about doing it. Subtract 2x to get them to the right where they are bigger. These cancel, bring down the -5. 6x minus 2x gives us 4x, bring down the +2. Now I will get the constants to the left by subtracting 2 from both sides. That gives us -7 is equal to 4x. Divide both sides by 4. And I know at this point you're probably realizing that it's not going to be a whole number. That's okay. It is possible to get decimals. We're going to leave it as a simplified fraction though, which would be x is equal to -7 over 4, also known as -7/4. On the right, we have an inequality. Same kind of process though. So subtract 4. I want to get my constants to the right. That's going to bring -6x is greater than 12. I want to get x by itself, so I'm going to divide both sides by -6. It's going to leave us x. We divided by a negative, so remember, if you multiply or divide by a negative, we need to flip the sign. Okay, so now it's going to be less than, and then 12 divided by a -6 gives us a -2. So final answer will be x is less than -2. All right, number 10, we have an absolute value. Our goal here will be to get the absolute value by itself, and then we'll be able to set up our two equations. So we're going to want to add 4 first. That'll give us 2 absolute value x plus 3. 12 plus 4 gives us 16. Then divide both sides by 2. That's going to give us x plus 3 is equal to 8. Now that we have the absolute values by themselves, we can set up two equations. So we know the x plus 3 can be equal to +8, and we know that x plus 3 can be equal to a -8. Subtract 3 from both sides. Turns out x can be 5. Okay, subtract 3 from both sides over here as well. X can also be a -11. On the right, we just have another equation that takes more steps. We'll do distributive property first. So -4k, 2 times 5k gives us a +10k. 2 times -6 gives us a -12. Bring down the right side. Then we'll combine like terms. -4k plus 10k gives us 6k. Bring down the -12 and then bring down the right side. I would then add 3k to both sides. That leaves us with 9k minus 12 is equal to -39. I would add 12 to both sides. That's going to leave us with 9k is equal to a -27. Divide both sides by 9. That's going to give us k is equal to a -3. All right, number 12. Solve the linear system by graphing. So we have the first one. Y is equal to -5/3 x plus 3. We'll graph the y-intercept first, which is at +3. Right, so that's B. M is equal to -5/3. I'm going to toss a negative to the 5, just a personal decision I made. So that tells me I'm going to go down and to the right. So 1, 2, 3, 4, 5. To the right, 3 gives me here. If I keep the pattern going, that gives me another point. Looks like we might be able to fit another point in the opposite direction. So then I would go up 5 and then left 3. Okay. These are equals. There's no inequality symbols here, so you can just connect them. You don't have to worry about shading either because they're not inequality symbols. Then we're just going to want to do the same thing with the other equation. So we have y is equal to 1/3 x minus 3. Y-intercept is a -3. Slope is 1/3. So we're going to go up 1, to the right 3. Up 1, right 3, up 1, right 3. Points in the opposite direction, down 1, left 3. down 1, left 3. And here we're interested in the points of intersection. So we're looking at that point right there. So your answer is going to be 3, -2, written as an ordered pair. All right, number 14 says solve the linear system using substitution. Okay, notice the top equation is in standard form. The bottom one is in y equals mx plus b. We know that y is equal to all this. I'm going to take that, substitute it into the second equation for y. So we have -3x minus 3. That's a rough looking 3. Y is equal to -5x minus 17. Close it up. It's still equal to 3. We'll do distributive property first. -3 times -5x will give us a positive 15x. -3 times -7 will give us a positive 51, and that's all equal to 3. Combine like terms, -3x and 15x will give us 12x. Subtract 51 from both sides. That gives us 12x is equal to -48. Divide both sides by 12. That's going to be x is equal to a -4. Keep in mind that's half my answer because I still need y. Technically, we can plug in that x value -4 into either equation. It makes a little bit more sense to plug it into the y equals mx plus b because y is isolated. So we have y is equal to -5x minus 17. Wherever I see x, I'm going to go ahead and substitute the value -4. Okay, we have -5 times -4, which gives us positive 20. Minus 17 will give us the y value 3. And then be sure to write your final answer as an ordered pair. So -4, comma 3 is our final answer. All right, number 14, solve the linear system using elimination. Now, we cannot add right away because the coefficients are different numbers. We can't subtract either for the same reason. At this point, you want to see if you can get away with multiplying one equation. And it really depends in this example which one you want to eliminate. So if I want to eliminate the x's, I could probably multiply the top equation by 2 to get both coefficients to be 4. If I want to eliminate the y's, I can multiply the top equation by 3 and accomplish the same thing. So I'm just going to go ahead and eliminate the x's just because it's the first one. So I'll multiply the entire top equation by 2. So that'll be 4x. 2 times y will give me positive 2y. And then 2 times -1 will give me a -2. Second equation will stay the same because the coefficient of x was already a 4. Okay. Now notice both coefficients of x are a positive 4. So the only way I'm going to be able to eliminate them is by subtraction. 4x minus 4x eliminates. 2y minus 3y will give me a -1y. Normally I don't put normally I don't put a 1 as a coefficient, but the fact that it's negative means that I still have some work to do. -2 minus 3 will give us a -5. And we're going to want to divide both sides by -1 to get rid of that negative. So y is going to be equal to a positive 5. And I'm going to go ahead and take that and plug it into one of the top equations. I'm just going to go with the top one. They both seem pretty easy. I'm going to plug that in for y. Notice I won't put parentheses because there's really no multiplication going on, so I can just replace it simply with a 5. I'm going to subtract 5 from both sides. We get 2x is equal to a -6. Divide both sides by 2. Turns out x is equal to a -3. And then I'll be sure to write my final answer as an ordered pair. So that'll be -3, comma 5 for a final answer. All right, for number 15, it says, for each solution method, explain how you know that a system of equations has one solution, no solution, or infinitely many solutions. Okay, if I were graphing and I had one solution, the two lines would intersect. Right, so it would look something like this. If I was doing substitution or elimination, I would get an actual ordered pair for xy. Okay. If there were no solution and I was graphing, that means the lines would be parallel, which means they would look something like this. If I was solving it by substitution or elimination, what I would notice is that the variables would eliminate, both of them. And super important, I would get a false statement. So for example, I might end up with something like 5 is equal to 0, which I know is not the case. If I was graphing infinitely many solutions, it would be the same line, right? So maybe I graph one line and it looks like that. And then I go ahead and I graph another line and I would find out that they're right on top of each other, which basically means that every single point is a point of intersection. If I were doing it algebraically by substitution and elimination, I would notice that, again, both variables would eliminate like before, but this time I would get a true statement. So most likely you'd get something like 0 is equal to 0, which you know, in fact, is true. All right, number 16 says graph the system of inequalities. Okay, so we'll start with the first one. You'll notice that these are actually sort of like in standard form. They're not in slope-intercept form. So the first thing we're going to want to do is get them in slope-intercept form. So we have 2x plus y is less than or equal to 5. I'm going to subtract 2x from both sides. Cancels on the left, bring down the y, that's less than or equal to, and then bring down negative 2x plus 5. I'm trying to get them into slope-intercept form, so y equals mx plus b. Okay, I'll go ahead and I'll graph that one while we're at it. The y-intercept b is 5, so that puts us here. The slope is negative 2. We want that as a fraction, so we know which direction to go. That's going to tell me to go down 2 and to the right 1. Down to right 1. And again, I'm going to do as many as I can because I want to make sure that my graph is very accurate. Okay, opposite direction, up to left 1. Based on that symbol right here, that's going to be a solid line. And then when it comes to shading, we're going to read this as y is less than or equal to 5. So here's my y-intercept 5. Values less than 5 would be located underneath. So I'm going to go ahead and shade everything underneath this line. Okay, now let's go ahead and graph the second one. So the other one was negative x plus 3y is greater than 3. I'm going to add x to both sides. Cancels. I'm going to have 3y is greater than x plus 3. Divide everything by 3. So we're going to have y is greater than. X divided by 3, technically x has a coefficient of 1, so I'm just going to write that as 1/3 x, so I can clearly see the slope. And then plus 3 divided by 3 is 1. So our y-intercept will be 1. And then our slope will be 1/3, which means we're going to go up 1 and to the right 3. So up 1, right 3, up 1, right 3, up 1, right 3. Follow the pattern backwards. Down 1, left 3. Down 1, left 3. Based on this symbol right here, it's going to be dashed. And then it says y is greater than 1. So values greater than 1 means we're going to shade above the blue line. And then to make my solution region, my answer very clear, I was supposed to be a highlighter. Didn't quite work out. I'm going to want to highlight the area that gets shaded by both colors. And there you go. All right, number 17. Bit of a word problem here. George is going to race his little brother. He gives him a 20-foot head start. George runs at a speed of 15 feet per second, while his little brother runs at a speed of 10 feet per second. Letting x represent the time in seconds, write an inequality that can be used to determine when George will be ahead of his little brother. Then go ahead and solve your inequality. So we're going to have George. We're going to have his brother. And we want to know when George will be ahead, so when he will be greater. Okay, so George runs at 15 feet per second, so we're going to have 15 times how many seconds he was running for. We don't know, but they called it x. His brother runs 10 feet per second, so 10 times x, plus they gave him a 20-foot head start. Okay, we can go ahead and solve that. We can subtract 10x from both sides. That's going to give us 5x is greater than 20. Divide both sides by 5. X will be greater than 4. So it will take George 4 seconds or more to catch up to George. All right, last one in the study guide. It says transform the given function as described and write the resulting function as an equation. Okay, so a is a linear function. We want to translate it to the right. So we're going to have f of x in parentheses x. We want it to go to the right, so that'll be a minus 3. And then we want it to go up 3 units, so we're going to add a positive 3 for k. And that's what the equation would look like. Okay. B is absolute value. Okay, so we want to translate left 1 unit. So inside the absolute values, because we want it to go left, we're going to do plus 1. And then we want it to go up 2 units, so our k will be a positive 2. C is quadratic. Okay, so we have f of x equals, we want it to stretch vertically by a factor of 2, so our a will be 2. Okay, we want it to translate right. That'll be x minus 4 squared, so that means our h is negative 4, so that we can travel to the right. And then k is positive 5 because we want it to go up 5 units. D is square root. Okay, so we have f of x. We want it to reflect, so there's going to be a negative a. We want it to compress vertically by a factor of 1/2. So a will also be half. And then we want it to translate down. There is no left to right movement, so the only thing underneath the radical will be x. Down 7 means our k will be a minus 7. And that is it.